Hello students, I am Chelma Reddy. Welcome to CR Maths class. In previous class, we have discussed concept up to definition of probability. Now continuation part. See here, odds in favor, odds against an event. Odds in favor, odds against. There are two types. See here. Let S be the sample space and E be an event. E complement denote the complement of E. Then odds in favor of E, odds in favor of even E, that is equal to number of cases favorable to event E divided by number of cases against E. Odds in favor of E means number of cases favorable to event E divided by number of cases against E. Favorable means n of E, against means opposite, n of E complement. This is the definition. Odds against an event E, that is equal to number of cases against the event E divided by number of cases favorable to event E, that is equal to n of E complement divided by n of E. So finally, odds in favor of event E is equal to P of E by P of E complement. Odds against event E is equal to P of E complement divided by P of E. This is the definition. Now see, odds in favor of E, it is denoted by P of A is to P of A complement. That meaning is P of A by P of A complement only. Odds against A, it is denoted by P of A complement ratio P of A. Okay. For suppose P of A is to P of A complement is equal to X is to Y. Then what is P of A? P of A means here observe that X divided by total. X divided by total. X by X plus Y. P of A complement. P of A complement means what is there here? Y. Y divided by total. Okay, students, P of A is to P of A complement given means how to find P of A and P of A complement. This is already you know very well. P of A means X by total. P of A complement means Y by total. Total means X plus Y. Okay. So here remember it, odds in favor of event E, that is equal to P of E by P of E complement. Odds against event E, that is equal to P of E complement divided by P of E. By using this concept in September 2020, one question given in mains. Remember it. Next definition, exhaustive events. Exhaustive events means a set of events is said to be exhaustive of at least one of them happens when experiment takes place, or the sample space is completely filled up by events as shown in figure. See, I will draw the one diagram, then you will understood very easily. This is total sample space. Now, this is A, the A part. Now, this part is B. Now, remaining part, we will say that C. Observe that A union B union C, that is equal to S. So, the sample space is completely filled up by events. Yes or no? Or we can say another way also. E1, E2, E3, and so on, En, are said to be mutually exhaustive events. Then E1 union, E2 union, E3 union, and so on, En, that is equal to null set. Sorry, sample space. Sample space. This is sample space. This is, we can write in short form, union EI, where I is equal to 1 to n, that is equal to sample space. In this case, we will say that E1, E2, E3, and so on, En are mutually exhaustive events. Mutually exhaustive events. In this case, there is no intersection part. See here. Now, I'm going to explain another example. Mutually exclusive events. Mutually exclusive event means two events A and B are said to be mutually exclusive events. Their intersection part is null set means we will say that A and B are mutually exclusive events. Or suppose, see the example. This is sample space. This is event A. This is event A. This is event B. Here observe that there is no intersection part. In this case, we will say that A and B are mutually exclusive events. Now theoretically, see the definition. A and B are two mutually exclusive events if happening of A rules out the happening of B, or vice versa. They cannot occur simultaneously in terms of set. This we will say that disjoint of A and B. Disjoint means intersection part is null set. So we can say another way also. Here the events A1, A2, A3, and so on, An of a random experiment are said to be mutually exclusive or disjoint events. That means here A1 intersection, A2 intersection, A3 intersection, and so on, intersection An, that's equal to null set. Null set. So A1, A2, A3, and so on, An are said to be mutually exclusive events. If you want diagram, see this. This is total sample space. This is A1. This is A2. This is A3. Now this is, or suppose, A4. Here observe that between the events, there is no intersection part. There is no intersection part. Finally, A1 intersection, A2 intersection, A3 intersection, and so on, An, that is null set. Okay, this is, we can write in short form like this: intersection Ai, where I is equal to 1 to n, that is equal to null set. So in this case, we will say that A1, A2, A3, and so on, An are mutually exclusive events. In this case, E1, E2, E3, and so on, En are, we will say that what? Mutually exhaustive events. Exhaustive means union part is sample space. Mutually exclusive means intersection part is null set. So this point, remember it. Okay.